Hi, it's Mrs. Pope, and today we're going to talk about properties of logarithms. Our goal is to simplify and evaluate expressions using the product, quotient, and power properties of logs. So we have three properties we're going to go over today. Starting here with the product property of logs, for symbol-wise, for all positive numbers a, b, and x is not equal to 1, log base x of a times b is equal to log base x of a plus log base x of b. So, for example, if you had log base 2 of 5 times 6, and notice it may not be written here as 5 times 6, it may be written as 30. It's just up to you to understand that that's the same as 5 times 6, or the same as 10 times 3. So if you had log base 2 of 5 times 6, that would turn into log base 2 of 5 plus log base 2 of 6. That's the property that we can use. So example 1, solve log base 6 of x plus log base 6 of x minus 9 is equal to 2. Well, let's use that property. We know if they're added, that's the same as being multiplied together. So this turns into log base 6. Instead of adding, now I can say the same base of x times x minus 9 is equal to 2. And why would we do that? Well, now we can get rid of that log because we're trying to... Our whole goal is to solve for x. Well, I can use the property of logs. I can take 6 to the power of 2 and set it equal to here. So 6 squared is equal to x times x minus 9. So I just used my property. So this is an entity right here. This is like the x. This is like the base to the power of the answer is equal to the big number. So now we can simplify this. So we have 36 is equal to x squared minus 9x. If we subtract 36 from both sides, we have it set equal to 0. So we would have 0 is equal to x squared minus 9x minus 36. Now let's factor it and solve. I can factor x squared minus 9x minus 36 into x minus 12x plus 3. One set equal to 0. If I have one answer would be 12 and the other would be negative 3. So those are my two answers. So again, I do need to check. I need to check and see if both of those work. So let's step over here and check. Let's check 12 back in the original. So log base 6 of 12 plus log base 6 of 12 minus 9. Is that equal to 2? So log base 6 of 12 plus log base 6 of, was that 12 minus 9? I can't even read my own writing. 3. So log base 6 of 12 minus log, is that equal to 2? Well, remember, if they are added, then we can go ahead and put them together and multiply. So this really means log base 6 of 12 times 3. Is that equal to 2? That's what we're trying to figure out. So is log base 6, 12 times 3 is 36. Does that equal 2? Yes, 6 to the power of 2 is indeed equal to 36. So this does work. Now let's try the other one. Log base 6 of, what is it, negative 3. Negative 3 plus log base 6 of negative 3 minus 9. Does that equal 2? Log base 6 of negative 3, I see some problems already. Log base 6 of negative 12, not going to work. Because of these negatives right here. You can continue going on, but you're going to see it doesn't work. As soon as you get a negative here, we may as well stop because it's not going to work. All right. Quotient property for all positive numbers a, b, and x, where x is not equal to 1. If you have log base x of a divided by b, that turns into log base x of a minus log base x of b. So example, log base 2 of 5/6 is log base 2 of 5 minus log base 2 of 6. So let's use this. Log base 3 of 56 minus log base 3 of n is equal to log base 3 of 7. So this may be all the information you have, and now you need to solve for the variable n. So what we can change this, using this, we can take, this is the 56, this is the n, this is like your a and your b. So if you have log, same base, a minus b, it's log base x of a over b. So this turns into log base 3 of 56 over n. And we want to see if, or we're going to set that equal to log base 3 of 7. Now look what we have. First we use the quotient property here. Now what we have is the property of equality. Because I have two logs, same base. So log base 3, that means these have to be equal to each other. 56 over n must equal 7. So if we solve that, multiply both sides by n, and then divide by 7, and it's going to be equal to 8. And you can check that one on your own and see if it works. Last property, power property of logs. So for any real number p and positive numbers m and b, where b is not equal to 1, log base b of m to the p, I know that sounds crazy, is equal to p times log base b of m. So really all that happens, this little p jumps down right in front. So example, log base 2 of 6 to the 5th power, that 5 jumps down and it becomes 5 log base 2 of 6. So simplify. Log base 5 of x cubed, if we want to, because we're trying to solve for x, eventually we would use this later to solve for x, we want to get rid of that 3. So it just comes down in front. 3 log base 5 of x. And that's it for the power property. Thanks for watching, and remember, you are responsible for your own learning.